All right, we've got earnings coming up tomorrow. I hope that you have some good numbers for me.
Excellent numbers, sir. Actually, the projections are fantastic. The next few quarters, I mean, we're going to be making a lot of money.
But what about our competition?
Well, the new Sandy Bridge architecture is going to carry us forward for at least the next 10 years. It's so far ahead that there's no way they're going to catch us.
10 years is all well and good, but as of this moment, who has the fastest CPU?
Well, the Intel Corporation, sir.
The Intel Corporation.
I think you've earned your cake. All right, earnings time again. We're all wearing our lucky outfits. We've got our lucky cake. How does it look?
It looks pretty dang good. We've gone from 93% market share to 95% market share.
That's not the largest number I've ever heard. What about on the hardware end?
Well, we've been tweaking the design, but we really haven't made a lot of changes.
Are we making evolutionary changes to go forward?
Not really.
Who has the fastest CPU in the world?
Well, the Intel Corporation.
The Intel Corporation.
Slice that cake. Here we are, it's earnings time. We have our ceremonial clothing, our ceremonial cake. What are the numbers?
The numbers are good. They're not bad. Nothing has changed really. We're still making the same amount. Profits are still good though.
That's not going to make the shareholders happy on the call. What about on the technology front?
Well, it's hard for us to get more market share. The competition is actually clawing back some market with Ryzen.
But what is this word?
Well, I mean, we've been on 14 nanometers for a while. We're trying to move to 10 nanometers, but...
Yeah, we should be doing that, right? I mean, why aren't we doing that?
Well, I mean, it's just 14 nanometers has been good.
Well, damn it, who has the fastest CPU in the universe?
Intel Corporation.
Still has the fastest CPU.
We'll cut the damn cake then. All right, you're probably wondering why I've told you to put on your lucky clothing and get the lucky cake. It's not an earnings call, but as I understand it, there's some sort of crisis spectrum.
A specter, and meltdown.
What is that?
Well, it turns out that we have some massive security issues, and the fixes are going to slow the processors down. And
slow is the opposite. Our goal is to go fast.
Yes, it's very problematic.
Is this going to affect our financials?
Yes, sir, almost definitely. We don't know the extent of the damage yet, but I mean, the amount of research we're going to have to do alone is going to cost us, who knows how much.
We don't even know how much it's going to cost.
So what percentage would you say we're looking at here as far as loss?
It's just going to be a problem after problem after problem.
This is a great deal of bad news I was not prepared for. But who has the fastest CPU in the universe?
Well, technically it's still Intel.
Yes, it's Intel. Cut the cake.
No, you don't understand. They're catching up with us. I mean, they've got a better process, it looks like, and they're catching up. And I don't think you understand the gravity of the situation because we don't have anything in the process node. There's no fixes in silicon. It's not,
All right, enough of this. Who has the fastest CPU in the world right now?
So what is the big question? What's the fastest? Obviously. Now, disclaimer. Yes, AMD sent me all of this stuff to test. Everything that you see in the video, I will be testing. And the big question on everybody's that was a slip. The big question on everybody's mind is how does this fare versus the 9? We've got the Radeon stuff too, but that's not in this video. Ryzen 9 versus the i9, Ryzen 7 versus the i7, 9700K versus the 9900K. That's basically where we are and what we're up to and the insanity. Geekbench, the i9, 9900K, 6034, 6034 in Geekbench. The multi-thread, it's about 34,000-ish, depending on different things that you might be doing. Cooling, if you got multi-core enhancement on. I did have multi-core enhancement on. The AMD 3900X, single thread, Remember, 6034 is the number to beat. It's about 5,900. Multi-thread, it's about 45,000-ish. So multi-threads, that's a pretty strong showing. Wah, wah. I mean, that multi-thread win is pretty significant, but it's all about the single thread and the lightly threaded stuff, right? Okay, so what about CPU-Z's built-in benchmark? The 9900K, maybe we can pull this off. Single thread, remember, multi-core enhancement, about 580. Multi-thread, almost 6,000. All right. Let's run the AMD 3900X. Ryzen 9. Let's see what this is. Oh, it's about 530, 540 single thread, but 8300 multi-thread. Wow, that's a, I mean, in the AM4 socket, 8300, that's pretty good, but, you know, that's it. I think Intel, you know, still the king of single thread. Why even bother doing a deeper dive? I mean, that's it. Show's over, right, folks? So, oh, wait, no, I'm getting a call. You sure? Oh, well, I mean, okay, if you're sure. Well, folks, Intel is saying that it's not about the artificial benchmarks anymore. It's about real-world performance. Well, you heard him. Let's take a deeper dive. You knew it was going to be more complicated than that, didn't you? Well, the dog literally caught the car, so it's just packing around a tire at this point. Let's take a look at some of AMD's slides. So, first up, the pricing. So, this Ryzen 9, which is a 12-core, is about $499 US. So, it's about the same price as the 9900K before the price drops, which have not been confirmed as of this video. Now, locally, I've got a Micro Center, which has always been a little bit below retail, especially if you buy like a combo motherboard deal. They're willing to take a little bit of a hit to get you in the store. So, I don't know if there's a legit price cut on the 9900K to take the wind out of AMD sales a little bit. There was the memo leak where Intel said, we're probably going to win on single thread and lightly thread, but as you'll see from my testing, in artificial benchmarks, that's true, but real world, that's not true. It's a tie or in favor of AMD, pretty much no matter how. I mean, I haven't done super comprehensive testing because I have not had like enough time with like the full version of everything. Unequivocally, I think AMD has got the better part, especially for the mainstream, especially for people that want a little bit more performance, but they don't need PCIe lanes, for example. They need the CPU horsepower. I think AMD's got the better product, but we'll get to that. We'll get to that. Of course, the Ryzen 7 3700X. Those are the CPUs we have. So we have the 3700X and the 3900X. That's sort of the top and bottom of the top of the stack, if you will, at least until the 16-core 3950X comes out, which, woo, I can't wait. Can't wait for that one. So, yeah, the 329 US, 499 US. So the 3700X really, you know, is comparable to the 399 9700K, but for 95% of things, it actually is probably better than the 9900K. Single thread, this is a little weaker, but owing to the not quite as good maximum boost clock. But, I mean, it's a 65 watt part, so it's going to be a little under. So it really does compare to the 9700K at 65, the 65 watt TDP. But if you enable PBO and let it stretch its legs a little bit, it seems like it's going to do almost as good as a 3800X. Now, while I'm shooting this video, I don't have a 3800X. But while you're watching this video, I'm in line at Micro Center to buy a 3800X. So 21% more performance, one thread with third generation Ryzen. So this slide from AMD has all of their other parts. So it's, you know, the 2700X, and it's like, look how much we improved over ourselves. Because if you compare yourselves to other people, it only leads to disappointment. Most of the time, not this time, obviously, but most of the time. But it's like, look, I'm improving myself. That's all that matters. Yes, there are people out there that will be better, but I'm improving myself, and that's how, you know, that's the healthy psyche. So you look at this and it's like, wow, this is really good. This slide is actually conservative. I think that probably, I mean, this is Cinebench R20 single thread. Again, this is not, doesn't seem to be with PBO or anything like that. My results generally were better than this as long as I managed the thermals, and I used the Fancy Pants X570 motherboard that could really let this new CPUs stretch their legs. One of the other things I talked about was the Windows 10 optimized scheduler. And a lot of people have gotten that wrong because it's like, oh, all of our game performance is going to be like magically better. So the Windows 10 scheduler, to be clear, benefits all Zen cores, all the way back to the original Zen, Ryzen 5, Ryzen plus Vega, literally everything. Windows 19.03, you do not need a driver for the new scheduler improvements. Everything is good. But if you retest a bunch of games, you will not see a dramatic uplift in average frame rates or even 1% lows or maybe even 0.1% lows. There is a little bit of a difference. And the other half of that is the thing that requires a driver, which is there's a Ryzen clock selection thing. Remember how we had to do like the balanced power profile? And this is because Ryzen would go from a low power state to a high power state. You really don't want to run your CPU at max clocks all the time because it'll limit how often it can boost to those like really super high, like XFR, even beyond the maximum boost specified by AMD, especially on the second gen Ryzen. And so you want it to very quickly be able to toggle between those clocks. And by default, on third generation Ryzen, it was taking about 30 milliseconds. With the driver, it takes 1 to 2 milliseconds. There's more to this story here because on second gen Ryzen with the balance profile, and surely it's not actually that slow. So there's a little bit more that I'm glossing over here. But with the chipset driver, there's basically no penalty for toggling between low power and high power states. And that's important if you want the maximum performance out of your CPU, especially for lightly threaded workloads. They talk about how Rocket League at 1080p low can be 15% better, and PC Mark for the webpage app can be about 6% better. I can reproduce that on the PC Mark side of things. I was able to reproduce a 6% uplift with Indigo and 7-zip, but especially on other stuff. But like for Threadripper, like the Numa thing with Threadripper, that's something different, and that's still broken. So the dev team that was working on the scheduler fix, good job. You all get cookies, but you need to keep working because I need that Numa issue fixed on the 2990. Oh, and by the way, 12 cores with 2 sticks of memory, I was right. It was definitely not memory bandwidth. I mean, I knew I was right, but here's another data point. I was right. I'm just kidding. I don't know. It's fine. It's all well and good. So I think GTA 5. Well, GTA 5 is one of the more interesting places where you can see the effects of the scheduler. But GTA 5 is weird because the engine itself is fundamentally broken when you exceed 140 FPS. When you're going faster than 140 FPS, there's a chance that something stalls in the GTA 5 engine and the whole machine will stutter. That is not the fault of the platform. That is not the fault of the CPU. There was talk of a lot of people saying that first gen Ryzen, like the 1800X, the 1700X, 1700 with GTA 5 was much smoother, and the reason for that was because the platform basically limited the maximum FPS that you could get at like 1080p. And so the situation was that because the FPS was limited, the engine was not breaking, and so you literally did have a smoother experience. There may have been other contributing factors, but trust me, I put in the work on that. That's 90% of what people perceive to be smoother from the GTA 5 engine. So it's really interesting to look at that on Ryzen 3000 because PCI Express 4 and the memory latency is much more consistent, if slightly higher. We'll talk about that. But overall, the effect is that things are actually better, and Ryzen 3000 can achieve those insanely high frame rates, and so Ryzen 3000 actually does experience the game-breaking stutters. So testing GTA 5 at 1440p and looking at the actual frame times, you can see when the frame rate is super high, that's during those scene transitions. But then sometimes in the middle of a scene, you'll have like a lot of really crazy spikes, and that's because in that particular part of the scene, for whatever reason, the system was able to ramp that super, super high. Now, contrast that to Far Cry 5. Far Cry 5 was another interesting one to look at because, if you remember, that's one of the games where SMT off actually improved performance. This game is one of the few games that I can actually see a legit performance uplift, a little bit of one, when you look at those long tail frame times on Far Cry 5, and you claw back a little bit more performance, and the game has been optimized a little bit since then. And because of those game changes since the original Zen launch, it's really hard to do an apples to apples comparison. But having done the testing with Far Cry 5 way back a long time ago, it does seem like Far Cry 5 is improved by the Windows 1903 scheduler changes. So that's nice to have under the hood. But most games, Steve from Hardware Unboxed did a lot of testing. Most games are not really like dramatically helped. You're not going to see a 15 or 20% performance uplift. I know that some people reported that, but Ryzen is really weird. When you overclock it too much, it can be stable, but your performance can regress. So when you're doing overclocking, you really need to dot your I's and cross your T's to make sure that it's like, well, the number is higher, but your computer's actually crappier. Sometimes Windows gets cruft in it, and you got to check that from time to time. That's going to be a big part of this launch too, because some people are going to install the Ryzen 9 and they're not going to have their connections right, or the thermal paste is not going to be right, or whatever, and they're going to run that single thread thing even in CPU-Z, and they're going to get about 490, and that means that something has gone wrong with your physical install. Either the cooler's not seated right, or you got a thermal paste problem, or your power supply is crapping out, or you got V-droop. You got a problem because that single thread in like CPU-Z is only like 490. You should be able to get 510, 20, 30 all day long. PBO, it's like 540, upwards of 550, no problem. So AMD's game slide doesn't really give you the numbers for Team Blue, but you can see that the graphs are pretty close. And this is with the Core i9 9900K versus the 3900X. So, we've got Black Ops, COD Ops, we've got COD Ops, Devil May Cry, GTA 5, Civ, Overwatch, CSGO, PUBG. PUBG's hard to test, and Rocket League. And if anything, this slide is actually conservative. The numbers that we were getting for a lot of these games were better. And we did our own testing. So like with Civ 6, generally, it is too close to call, or basically a win for AMD. For Ghost Recon Wildlands, it's a win for AMD. For Shadow of the Tomb Raider, which has typically been an Intel title, I think, at least in my testing, basically it's a win for AMD. Even at like 1080p, the only places where Ryzen loses by a few FPS is when we're talking about 1080p past like 190 FPS. It's like 187 FPS on the Ryzen 9 to like 192 FPS on the i9. So AMD's got this slide where Ryzen 9 3900X comparable gaming performance, 47% creative performance, 58% energy efficiency, and the first for PCI Express 4.0, which the PCI Express 4.0 SSDs, Gigabyte is launching a 2 terabyte PCI Express NVMe SSD. I don't have final pricing for that yet. I think it's $250. I think I'm at Micro Center right now buying another one. So 200, 250, somewhere through there. Perfectly reasonable if you want absolute top tier performance. Now, I think that, we'll talk about that more in a second. So SpecView Perf. What about SpecView Perf? Generally, AMD is going to win there because of the multi-thread, but even the lightly threaded stuff, it's really close. Intel wins a few technically, but using those applications, you would never know a difference. So like, unlike Ryzen 2700X, where the performance difference was like 5 to 10%, typically the performance difference here is less than 5%, and you're not going to know, and even if you did know, you're going to have a better experience in the multi-threaded scenario. So I really don't think Intel wins here. So let's talk about our test platforms. We have two systems that we use for testing. We've got the ASRock Taichi X570. It's a great board, solid. It's got a really clean UEFI. It's solid board testing. We tested that with both the 12 core and the 8 core, the 3700. It's a 65 watt part. Come on, you could run this on a Tomahawk, an MSI Tomahawk B450, which is coming in another video. So yeah, very impressed with the Taichi. It's a solid board. It's got an aesthetic. Comes with a Torx bit. It's pretty cool. There's going to be a completely separate review on that motherboard. Our other system is a Gigabyte Aorus Master. The Aorus Master is the X570. It does have a chipset fan. Some people have said, it doesn't have a chipset fan. That is incorrect. It does have a chipset fan. The Aorus Extreme is the one that does not have the chipset fan because the entire motherboard is a heatsink. Yeah, these motherboards are just completely nuts. The Aorus Master puts the NVMe slot that is closest to the CPU as the one that is wired directly into the CPU. That's not necessarily the case with other motherboards. But the situation is that these motherboards are super, super, super solid. We tested it with a bunch of different graphics cards and a bunch of different PCI Express peripherals. I did IO MMU testing. That's going to be on the Linux channel. There's another video you can watch after this one on the Linux channel that's going to be pretty great. Yeah, the 2 terabyte SSD really is awesome. If you're not familiar with the overall platform of X570, it's PCI Express 4. So the chipset on the CPU, well, the IO die on the CPU interfaces with the chipset on the motherboard, and it's actually the same piece of silicon, just wired up some different ways. So it's a PCI Express by 4 connection, PCI Express 4.0 by 4, which is double the bandwidth of PCI Express 3, between the IO die and the chipset. And then the chipset provides a number of PCI Express 4.0 lanes, as well as USB and other interfaces. But the PCI Express chips, the PCI Express lanes off of the chipset are also PCI Express 4.0. So if you run a couple of PCI Express 3.0 SSDs, it's not really gonna bottleneck because you've got 8 gigabytes per second link between the chipset and the CPU. Right now, if you wanted to run like a RAID 0 of NVMe, those NVMe do need to be connected to CPU lanes. So you're not going to be able to run a RAID 0 off of your chipset lanes. You would have to run one in an add-in card, like a PCI Express add-in card, and one in the NVMe slot that's connected to your machine, unless you boot from OneDrive and run a RAID configuration off of the other 2 NVMe that you're not using, like AMD's RAID. Now, some people want to talk about IPC and IPC uplift. We're at a situation right now where a 4.6 gigahertz peak single thread clock, what you get out of the 3900X at maximum, is faster than a 5 gigahertz Intel Core i9 9900K. It appears to me that every single instruction at parity with every single instruction from Intel, no, because they're different microarchitectures. But in general, it looks to me like AMD is slightly ahead of Intel here in the IPC war. So in general, I think it's a fair statement that AMD is ahead of Intel in terms of realized IPC. Now, some of that might be cheating with the giant L3 cache. AMD's calling that game cache because they don't, I kind of get that people that are shopping for a CPU might not necessarily understand L3 cache and what it is, but the cache, the L3 cache, the game cache on the CPU absolutely is monstrous. And even though it's a victim cache, it doesn't matter. You've got so much of it that you can just throw it around and do whatever, and that's gonna really help things. They also made advances in the integer unit, the floating point unit. You've got more of it now. The caches are smarter. And all of these things, all of these improvements, not just, it's like, let's just make the cache giant, lead to a better single thread high performance. They also have a Tage branch predictor, which is in and of itself a really cool computer science innovation. They still have the Perceptron network at the low level from what I understand, but the Tage branch predictor is sort of a secondary thing, and it can be up to a 60% improvement. And so again, all of these things contribute to this dramatic IPC uplift this generation. So after having worked on this stuff for a little over a week, what tips would I have for you if you're building a system like this? All right, first off, if you're going to do the PCI Express 4.0 thing, try to make sure that your NVMe goes direct to your CPU. It's better. And where that is in the motherboard varies from every different vendor. Because they're all PCI Express 4.0, just some are connected to the chipset and some are connected to the CPU. There is no performance penalty unless you go like 3, and then it's going to be cutting it close. But generally, you want to make sure it's connected directly to the CPU, especially if you decide to RAID later, but it's just lower overhead if you do that. Double and triple check your thermal paste and cooler. This Ryzen 3000 is highly sensitive to if you don't get your thermal paste right, especially if you want to do precision boost overdrive, especially for that single core boost, even on the 65 watt part. It comes with really good coolers. I don't think you're going to need an aftermarket cooler, so even though the processors cost the same, you don't have to buy a cooler. So you're going to save $50 to $100, even though the Ryzen 9 price is the same. I guess you make that up a little bit in motherboard costs, because there are some pretty cheap Z390 motherboards, although there are some pretty cheap X570 motherboards too, so I don't have a full suite of retail pricing by the time I'm doing this, so double check your prices. But I think apples to apples, even with the Ryzen 9, I think it's going to come out slightly cheaper, even if you want faster memory, which is not something we've talked about yet, but that's one of my tips is faster memory. So the way that the memory works here is like 3600 is the sweet spot. So if you can get 3200 to 3600 with good timing. So what does good timings mean? So it means the relatively low numbers. So like 3200, 14, 14, 14, 34, 1T, command rate 1T, that's pretty good. You'll be happy with that. 3600, like 14, 15, 16, like 16, 18, 18, 16, 16, 16, 14, 14, 14, like 34, 36, 38, command rate 1T. You're going to be pretty happy with that memory as well. If you go past 3600, then the Infinity Fabric on the inside of the CPU decouples from the memory speed, which means that they run asynchronously. There is a little bit of a latency penalty with that. So for me, for my testing, I was running with memory that had a latency as measured by Ada64 of about 69 nanoseconds. And that 69 nanosecond latency is pretty good. I mean, it's a little bit of hand tuning, a little bit of fine tuning, because I'm running with that faster G-Skill Trident Z Royal memory, which is crystal and it looks all cool and it's really awesome, and it was included in the AMD review kit or whatever. But I also tested other kits of memory that I had here from AData and a lot more kits from G-Skill, like the Ripjaws, which the timings are a little worse. There's like 19, 20, 20, 22, and it does affect your performance, your 1T performance and your multi-thread performance, but not dramatically. But if you want to squeeze all the performance out of it that you can, you definitely want to go for the 3200 to 3600 memory sweet spot. Now PBO works a little differently. PBO is the Precision Boost Overdrive. It's like the overclocking with Ryzen, and that's not really unchanged. I'm not going to recommend that you do manual overclocking on Ryzen. That was true on first and second gen. Like, just letting it manage, the CPU manage it itself is fine. But they do give you a little bit more tuning and control this time on X570 motherboards. At least I haven't seen this feature on not an X570 motherboard, but that might change, although I kind of doubt it. And that is auto overclocking. You can get an extra 200 megahertz out of your chip up to with auto overclocking if your power and thermals and everything else are good. But your chip also has to be good, because I've got a 3900X and I could get 4.65, maybe 4.675, but some instability started to creep in. Now you can get up to 200 megahertz, but remember, even on liquid nitrogen, we were seeing maximum clock speeds of like 5.3 or 5.4, and we're getting close to 5 gigahertz with just standard liquid cooling. So, that extra 200 megahertz from the auto overclocking, unless you've got a super cherry CPU, I think it's going to be like 25 or 50 or 75 or maybe 100 at the high end. Now at the low end, if you're rocking a Ryzen 5 3600 or you get the 3700X, that will change your world, because the 3700X, when you really open it up, you're going to be within spitting distance of a 3800X. A 3800X is just a better bend 3700X for clock speed and frequency. So PBO, it's new, it's different. Just keep that in mind. PCI Express 4. PCI Express 4 can be a bit finicky, especially if you have a lot of devices in the system. So I was mixing a couple of PCI Express 4 peripherals with PCI Express 3 peripherals, and I really had to, sometimes the system was weird about posting. It seems like those issues are going away with newer BIOSes, so I'm gonna reserve judgment on that. If you're thinking about running Linux on these, you definitely want to check out the Level 1 Linux channel. There's a video there. The video's already out, so if you want more, you need more information, go watch that video, and check out the Level 1 website, because there's going to be a lot more stuff there that went up with that as well. So, there it is. The hype train. The Hogwarts Express hype train. Yeah. It's legit. I can see why AMD would be worried about, doing the whole Sound of Music thing and, singing The Hills Are Alive with the sound of clock speed or whatever. But they really should, because I think they've got the better product. They managed to pull off an incredible feat of engineering. I mean, Intel's a juggernaut. They have a ton of software engineers, a ton of people working on optimization. They have their own process internally. AMD and their partnerships with companies like TSMC and Global Foundries, which, both Global Foundries and TSMC bits of silicon are in this thing, I think. Pretty sure. Well, if you count the chipset. Well, the chipset is 12 and 14, so yeah. So we're talking the whole, AMD's really... AMD and the gang have really pulled this off, and it's really completely insane. And we also got GPU launches. So, AMD not content to rest on their laurels. They're doing GPU things. The GPU video is going to be a little different, though, than this. I mean, artificial benchmarks aside, AMD is demonstrating clear leadership here. I mean, yes, in the artificial benchmarks, Intel is still winning a little bit in single thread, but real world, it's a tie at best if AMD's not slightly in the lead, real world. And what a time to be alive. I'm Wendell, this is level 1. Hopefully I didn't screw anything up too bad. Come hang out in the forums, let me know if I missed anything. Got it kind of rushed to get this out the door, so if I got something super wrong, go easy on me. But basically I'm pretty impressed by what I see. Over and out.